Welcome everybody to the Ceph Tech Talk. I'm Mike Perez, your Ceph Community Manager, and I have the delight by Red Hat Emerging Technologies giving us a couple of interns, Jason and Nia, who have been working on a project related with Ceph. It is called Edge Application Streaming Multi-Video Sources. And it's their summer intern project, and so I'm really looking forward to hearing from these two on what they've been working on. So Jason and Nia, will you please take it away?
Yeah, hi everyone, my name is Jason Wang.
And my name is Niharika Kompala.
So this summer we worked on an Edge application that streams multiple video sources. And as interns in the office of the CTO, we work with emerging technology related to edge and cloud computing. So video streaming was a topic we saw that could be incorporated into emerging technology. So as there are billions and billions of cameras in the world doing everything from security to simple video chatting, there's always a need for improvement, whether it's quality or latency-wise. And then so this summer, our goal was to work on one such use case.
So what we'll be discussing today is the use case. We have picked the architecture we have designed to solve the issue. We'll be speaking about our components in the architecture, and we'll show a demo video of our progress. Next slide. Yeah, so why move to Edge? Although core networks and the centralized cloud architecture already support the use of smart devices to an extent, they will be unable to handle vast amounts of data that will be created at the edge by over like 75 billion connected devices that are predicted to be active by 2025. So our use case application is streaming video from multiple sources and stitching them together. It's like a part-by-part live stream of a sporting event or a concert or a remote learning class. And from these multiple video sources, we take the video, which processed, it's stored, and then we stitch the video together at the end to produce a 360-degree pano view of the live event. Next slide. After all, smart devices and other real-time cloud-based collaborations or communication applications frequently require low latencies that the traditional core network architectures and the legacy data centers cannot provide. As Jason said, like there are billions of cameras or devices that are like connected in different components of our day-to-day life that are streaming data, that has so much of data that is currently being processed on cloud. We are bringing them to with the upcoming 5G architectures and technologies, trying to process them at the edge sort of pushes the speed, increases it, the latency and all these issues are handled that way. So there is the need for more speed. The gravity of the data and the computation has shifted from core to edge as a result of technologies like Internet of Everything, AI, ML, cloud gaming, HD streaming, VR. So we are predominantly talking about HD streaming services. Next slide. So we're going to talk about our architecture that we have designed. To go through it briefly, we have YouTube, and like our video source can be from YouTube or webcam or any such sources. These are streamed using GStreamer. We have built a GStreamer source, GStreamer plugin. We are already using a source plugin, Soup HTTP SRC, that's already available to stream from our live source. We've built the sync plugin. So our sync plugin basically uses S3 API to upload video to Ceph from it's buffered live, and it goes to Ceph, and we're using the multi-part approach here. So once all the paths have been uploaded to Ceph, we have set up Ceph bucket notifications. So once the notifications come up, the Knative functions get triggered, and the Knative functions here performs the necessary and required like here in our case, we are using OpenCV to do video stitching. So such analytics or anything based on our requirement can be done. Next slide.
So just a little bit more about our GStreamer plugin and what GStreamer is. So the goal for our plugin was to upload videos to Ceph with a GStreamer pipeline. And basically, GStreamer is a framework for creating streaming media applications. And GStreamer makes it very easy to write any type of streaming multimedia application. So although GStreamer had many useful plugins, there's no sync element into Ceph. So like Neha said, the source element that we used was already provided for us, which was soup HTTP source plugin. And basically that plugin is able to read data from a remote location given a URL. And then the sync element is what we created a custom RGW sync in Python using GStreamer Python bindings. And multi-part upload is how we uploaded to Ceph object storage. And basically we used multi-part upload instead of single part upload because we know that objects are limited in Ceph, and multi-part upload also limits the number of objects being uploaded. So that was one reason. And then to talk a little bit more about the properties of GStreamer. So G properties are really important because they control how the element behaves. In our sync, the properties that we have are the Ceph credentials, which is your endpoint, your access, and secret keys. We also have bucket, which is the bucket name we upload the file to. We also have part size, key, and limit size. So for our project, the end goal was to be able to stream live video. So we needed a way to tell the plugin to stop running and complete the multi-part upload, which is why we have a limit size. So once that size is reached, multi-part will complete its last upload and finish. So we had some issues running GStreamer on Fedora. And basically, we were able to write the code, but we couldn't find, there was no folder for the plugin for us to export to. So the way we worked around this was we created a container. So we found out that GStreamer ran better on Ubuntu. So that was our base, our custom base image with all the GStreamer packages and libraries. And then we also had a Python virtual environment to run everything.
So not just making it like a Docker image, we have also set up a package which can be installed using pip install. So there are some export conditions that have to be run after installing our Python package. But once you do this in your local system, be it on any OS, you can use the GStreamer. Next slide. Yeah, so now once the multi-part upload has been done, we set up bucket notifications, and once either a bucket is created or the bucket has been deleted, such events trigger the notifications, and once the notifications comes up, the knative function is triggered. And as I said, any analytics can be, any analytics or any features can be set up there. In our case, we are using OpenCV to stitch functions because that seems related or connected to our streaming source. Next slide.
So we use OpenCV to stitch our videos together. And basically we would capture the videos with video capture, and then we would read the frames. So the techniques we use with OpenCV is key point detection, which basically maps the points in one image to the corresponding points in the other image. And for us, we need at least 4 matches. And we also used fixed homograph matrix. So this meant that the key point detection and the feature matching is done once at the start, and then the key points are used for the subsequent video frames. So this will reduce computational cost, but the only really important thing to know is that the video must be fixed. So, or the camera that you're shooting has to be still. So here's.
Now I'll just walk you through the code of our plugin and the whole setup. So if you look at our basic sync code, we have all the parameters that Jason talked about, our Ceph credentials, the path size, the limit size, and when we want the streaming to stop and such details. So at the beginning, we set up our Goto client and we start the multi-part upload. Then, because this is live streaming, we get in buffer by buffer. Once our minimum path size limit has been reached, we call the handle part function. Handle part function is where part by part of the live streamed data is uploaded, and as a result, an e tag of that particular upload part is stored. Once all the paths have been uploaded, the minimum path size is actually 5 MB, but in this case, the last part can be of any size. And once all the paths have been uploaded, we do the complete multi-part upload to finish the process. And because we have multiple sources, we're streaming from multiple sources, we have written a pipeline function where we, as a one-time say, give our Ceph credentials. And we call a function where we give our command line, the GStreamer basic command line. As you can see, the soup HTTP SRC, we're streaming live, that's our source. And there's our sync Ceph RGW sync plugin. We keep giving our individual sources and bucket names for those sources. And we call the pipelines. So that's the basic part of our code, and we have packed the whole thing, we have containerized the whole thing. The Ubuntu is our basic setup where all the requirements for GStreamer are already downloaded and set up. Then we clone all our requirements from Git and we set up a Python virtual environment. There we, once we downloaded our GStreamer plugin, we export it and we inspect it and we call our Python function. So this is basically our whole code review. And so all of this has been packed into just one line. So if you want to use this plugin, you can just run this particular podman command that's available in our Git homepage. And how it works, I'll be showing you the demo right now. So once you run that podman command, you have to give your Ceph credentials, the endpoint URL, the secret key, access key, all those details. So here for the demo sake, we are inputting this in runtime, but you can set it as environment variables. That option is also available. So if you're doing this multiple times, it becomes easier. And the default size is 5 MB. Here I've just given it 6 million bytes. And because this is live stream, we have kept 60 million bytes as the limit to stop the upload. So intuitively, you will have like 10 paths. I'm giving, for this demo purpose, we're giving 2 videos right now. So I'm giving my first video link and I've defined the bucket name as Neha Wright. So as I said, we're expecting 10 paths to be created and you can see 10 paths have been created. I'm going to give my second source. Actually, when this has been implemented in real life, we'll be using threading process because this all happens parallelly. But for much more clearer understanding, we are giving it as part by part here. Once it's done, you just give done.
So here, I'm just going to show you how our stitching function works. So like I said before, an important part when we're shooting the video is that the camera needs to be fixed. And so when I was shooting my own videos to test, my camera was very shaky because I was just filming on my hand. So basically, to find a better video to show this demo, we cropped a video into 2 sections, which is what you're seeing here. And then the reason why we recorded this on Mac was because the Fedora UI was unable to play back our video. So, and then on Mac, we were able to stream it fine. So the left and right are the individual videos that you saw Neha upload. And then from there, it's uploaded to Ceph, and then our stitching function takes those videos from Ceph and stitches them together. And that's what you see in the result.
As you can see, this process or this architecture could simply have Kafka in it. But the reason we have chosen Ceph is one of the most reliable and stable storage platforms out there. And so when we're talking about live streaming and there's a lot of data, like high definition data and few GBs of data that gets recorded during these live streamings, Ceph has the ability to handle the amount and also the types of storage.
I think we can stop here.
Might I recommend in the future videos of octopus cephalopods?
Yeah.
That's really cool though.
So for future work, once the 360 video is stitched, you can see we re-uploaded back into Ceph, and as an extension of the current work, we can create an RGW NFS gateway to export the 360-degree stitched view, export it to NFS share, and then do RTMP video streaming from there. So yes, this is the work we have done till now. We'd like to thank Waman and Harrison, who have helped us these last 3 months. And no matter where we were stuck, their valuable inputs have helped us come till here and to be able to present this demo to you all.
And we'd also like to thank Mike and the Ceph team for allowing us to show our demo in our project here. So thank you very much.
Hey, not a problem. I'm happy to have any content. Thank you both for presenting. This was a great overview. I think I was really impressed with the stitching work myself. So, audience, do we have any questions? Yes. You can also put your question into the comments too. If you don't want to use audio, that's fine.
Can you explain a bit more about how the bucket notification Knative integration works?
Actually, the bucket notification, we've had an implementation issue here, but it's like, so when the bucket either gets created, we'll be creating the topic storage and we'll be creating the bucket names. So if there are multiple sources, probably we'll name it something like bucket 1, 2, 3 or something like that. So once we'll automate the process by, in case this particular bucket is created, we'll probably trigger a notification. So once, and we set a HTTP port. So once the notification has been created, it will trigger the Knative function, and Knative analytics will be containerizing the whole process. So it will run the analytics. So basically here it will, once the notification is triggered, it will run the OpenCV function where that particular bucket content is downloaded and then they're stitched together. Yeah.
Oh, go ahead. Sorry.
Is it pushing the notification, or is the Knative side polls for the notification? Because I know there are a couple of modes, different modes for that.
So I think it's get. As I said, we've had some implementation issue over there, so we were not able to thoroughly explore that part.
All right, thanks. Mike.
Somebody was asking in chat the URL to the GitHub project.
Oh, yeah.
Do we have any other questions in the audience? All right. That's a lot of awkward silence. So, all right. I want to thank Jason and Neha for going ahead and providing us this great content on streaming multiple video sources stuff. Very awesome. And also understand too that this is the end of your program. But I hope to see you in the community and join us in future projects.
Yeah. Thank you for having us.
Thank you very much.
Yeah. All right. Thanks everybody for joining us. And we have another Tech Talk happening August 28th. I believe I keep saying 1700 UTC. That will be the secure token service layer on top of Freightos Gateway. So come join us for that. And again, thank you, Jason and Neha, for joining us. And we'll see you all next time.
Thank you.
All right.
Yeah.
All right. Take care, everyone. Bye.